At approximately 700 million light-years from where you are currently sitting, the architecture of the cosmos collapses into an anomaly of staggering proportions. Here, the ambient temperature hovers mere fractions of a degree above absolute zero, a cold so severe that it strips the kinetic energy from atoms. There are no stellar nurseries. There is no cosmic dust. There is no light. It is a spherical volume of emptiness so immense that it stretches nearly 330 million light-years across. If you were to drop our entire Milky Way galaxy into the dead center of this sphere, the night sky above Earth would be entirely black, beyond our own local stars. We would not have even known other galaxies existed until the invention of deep space radio telescopes. We would have lived and died believing ourselves to be entirely alone in an endless black ocean. Yet this region is real. It is a physical coordinate in our universe, a gaping wound in the map of the observable sky. The surrounding superclusters of galaxies form a glowing structural shell around it, but inside there is an absence that defies the fundamental models of astrophysics. In a universe governed by the relentless pull of gravity, where matter is forced to clump together to form galaxies and solar systems, a void of this magnitude should not have had the time to form since the dawn of the cosmos. The mathematics of our cosmic evolution simply do not allow for a spherical tomb of this size to exist naturally. To cross it, traveling at the speed of light, the absolute physical speed limit of reality, would take 330 million years. During that journey, a beam of light would encounter almost nothing. No stray atoms to scatter it, no significant gravitational wells to bend its path. Just a relentless, freezing silence. Imagine standing on a dark shoreline, shining a flashlight into a fog so thick that the beam simply vanishes into the moisture. Now stretch that fog across millions of millennia. We are biologically conditioned to measure distance in hours or days, reducing the space between 2 points to a simple, manageable commute. We think of empty space as just a road connecting 2 destinations, but outside the razor-thin atmosphere of our planet, distance is not a road, it is a physical barrier. It is an absolute quarantine. The sheer volume of empty space separating stellar objects is so extreme, so unfathomably hostile, that it turns the universe into a collection of isolated islands, each burning out in absolute solitude. When we point our most advanced orbital observatories toward these deep, dark coordinates, we are not looking for something that is there. We are trying to measure the crushing weight of the absence itself. And the more precisely we map the empty spaces between the stars, the more a deeply unsettling physical truth emerges. The vastness of the universe is not a canvas waiting to be explored by future generations. It is an insurmountable gulf, a physical mechanism expanding faster than the laws of physics will ever allow us to cross it. The space between things is growing, ensuring that almost everything we can observe right now is already permanently out of our reach, trapped behind an invisible horizon that we can never, ever cross. We are terrestrial creatures, born on a sphere of dense rock and liquid water, wrapped in a comforting blanket of atmospheric gases. For hundreds of thousands of years, our brains evolved to process distances that could be crossed on foot, measured by the rising and setting of the sun, or defined by the exhaustion of our muscles. We learned to perceive space simply as the empty air between 2 objects. A room, a valley, an ocean. Our biological intuition tells us that distance is merely a temporary inconvenience, a gap that can be closed if we just move fast enough or build a machine capable of carrying us. This is the fundamental arrogance of human perception. We project our planetary experience onto the cosmos, treating the universe as if it was simply a larger version of our own world, a dark ocean waiting for our ships to cross it. But the universe does not care about our biological intuition. The space between the stars is not a larger version of the air between 2 cities. It is a completely different physical regime, a domain of extreme physics, where the rules of our daily reality are rendered completely irrelevant. To understand the true nature of cosmic distance, we must strip away the comforting illusions of science fiction, where ships warp across galaxies in an afternoon, and look at the terrifying, unyielding coldness of the raw data. The true scale of our isolation began to reveal itself not in a sudden flash of profound insight, but through decades of painstaking, almost maddeningly tedious observation. In the early 19th century, astronomers were engaged in a desperate hunt to measure stellar parallax, the slight apparent shift in a star's position as the Earth orbits the Sun. For centuries, the stars had refused to move. The greatest minds of multiple generations pointed their brass and glass instruments upward, trying to detect even the microscopic wobble that would finally allow them to triangulate the distance to a neighboring sun. The lack of movement was a mathematical nightmare. It implied either that the Earth was stationary, a relic of medieval thought, or that the stars were so unimaginably far away that the Earth's entire orbit, a sweeping circle hundreds of millions of miles wide, was mathematically meaningless from their perspective. In 1838, a German astronomer named Friedrich Bessel finally cracked the celestial vault. Operating out of a freezing observatory in Königsberg, Bessel focused his specialized telescope on a dim binary star system known as 61 Cygni. He did not have supercomputers or digital sensors. He had his own freezing hands, the grinding of brass gears, and an obsessive, unrelenting patience. Night after night in the biting cold, he measured the microscopic discrepancies in the star's position against the background glow of the Milky Way. When he finally completed the mathematics, translating the tiny angular shift into physical distance, he did not discover a new neighborhood of stars. He discovered an abyss. Bessel calculated that 61 Cygni was roughly 67 trillion miles away. It was a number so violently large that it instantly reduced the entirety of human history, all of our empires and wars, to a localized microscopic event. The human mind cannot process 67 trillion miles. If you were to drive a car at highway speeds towards 61 Cygni without ever stopping for fuel or rest, the journey would take you over 100 million years. And this was not a distant galaxy. This was one of our closest neighbors in the immediate local structure of the Milky Way. Bessel's discovery was a brutal assault on our cosmic ego. It was the moment humanity was forced to look down and realize we were standing on a single grain of sand, surrounded by an ocean of nothingness so vast that it bordered on the absurd. But raw numbers alone do not capture the profound hostility of these distances. To truly grasp the horror of the void, we must understand the absolute physical speed limit of reality, the speed of light. We often hear this term thrown around as a simple metric of velocity, a beam of photons racing through the vacuum at roughly 186,000 miles per second. At that speed, you could circle the Earth's equator more than 7 times in a single heartbeat. It sounds infinitely fast, but the speed of light is not simply a measure of how fast illumination travels. It is the maximum speed of causality. It is the absolute limit at which any piece of information, any gravitational wave, any consequence in the universe can propagate from one point to another. When we apply this ultimate speed limit to the distances Bessel and his successors uncovered, the terrifying nature of the universe snaps into focus. Light is excruciatingly, agonizingly slow. The distances are so catastrophic that they turn the speed of light into a microscopic crawl. Imagine the sun, the gravitational anchor of our entire planetary system, were to simply vanish this exact second, vaporized into nothing. Our biological intuition assumes that we would instantly plunge into darkness and spin out of orbit. But we would not. Because the universe enforces a strict speed limit on reality itself, the absence of the sun's light and the absence of its gravitational pull would have to travel across 93 million miles of space. For 8 agonizing minutes, the Earth would continue to orbit a ghost. We would continue to bask in the warmth of a star that no longer existed. The sky would remain bright. Children would continue to play in the sunlight. The illusion of reality would persist until the wave of consequence finally slammed into our planet. That is an 8-minute latency in reality, just for our own local star. Now, push that concept out into the deep ocean. When we look at 61 Cygni, we are not seeing it as it is right now. We are seeing it as it was over 11 years ago. The light hitting our retinas tonight is an ancient artifact. If that star exploded a decade ago, we would have absolutely no way of knowing. The information is still in transit, crawling across the freezing void. This means that every time we look up at the night sky, we are not looking into space. We are looking deep into the past. The universe is a graveyard of delayed echoes. The farther out we look, the deeper into history we sink. When we point our orbital telescopes at the Andromeda Galaxy, the nearest major galactic neighbor to our Milky Way, we are capturing photons that began their journey 2.5 million years ago. Before modern humans even existed, before our ancestors learned to control fire, that light was already traveling through the dead vacuum, dodging rogue planets and molecular clouds, just to strike a mirror in Earth's orbit today. If an advanced civilization in Andromeda were looking at Earth right now with an impossibly powerful telescope, they would not see our cities or our satellites. They would see primitive hominids wandering across a prehistoric landscape. This absolute restriction of causality means the universe is deeply, fundamentally fragmented. We are trapped in a local bubble of time. We can never interact with the present universe. We can only ever observe its decaying past. And yet, the physics of our isolation grow even darker when we examine our own attempts to cross these distances. We view our space probes as triumphs of engineering, and they are. Voyager 1, launched in the late 1970s, is the farthest human-made object from Earth. It has been flying through space at over 38,000 miles per hour, day and night, for nearly half a century. It has pierced the heliosphere, the magnetic bubble generated by our sun, and entered interstellar space. It carries a golden record, a message from humanity, a beacon of our existence. We celebrate it as our first step into the wider galaxy. But the mathematics reveal a merciless truth. Despite traveling at speeds that would vaporize a terrestrial aircraft, despite decades of relentless outward momentum, Voyager 1 is going absolutely nowhere. To reach the nearest star system to our sun, Proxima Centauri, a probe traveling at Voyager's current speed would need approximately 73,000 years. Let that sink into your mind. 73 millennia. All of recorded human history, from the first cuneiform etched into clay to the digital age, is a mere 5,000 years. You would have to repeat the entire span of human civilization almost 15 times over, just to wait for a piece of dead metal to drift past the absolute closest star to our own. Voyager is not an interstellar traveler. It is a message in a bottle thrown into an ocean so impossibly vast that the bottle will outlive the planet that created it, likely never washing up on any shore, drifting in the permanent dark long after our sun has swallowed the Earth. This is not a matter of needing better engines or waiting for technological breakthroughs. The distances involved are so extreme that they mock the very concept of biology. Organic life, with its fragile cellular structures and incredibly brief lifespans, is simply not engineered to cross the cosmic quarantine. The radiation environment of deep space, the relentless bombardment of high-energy cosmic rays, the physical degradation of materials over millennia, all of these factors compound the brutal reality of the math. We are prisoners of scale. The universe has imposed a hard physical barrier between its islands, a barrier of pure distance, enforced by the absolute limits of light and time. But the horror of the void is not merely static, it is active. In the early 20th century, an astronomer named Edwin Hubble peered through the massive Hooker telescope in California and noticed something terrifying about the light arriving from distant galaxies. The wavelengths were stretched, shifted toward the red end of the spectrum. The implications of this simple optical shift shattered the bedrock of physics. The galaxies were not simply drifting through a static void. The void itself was expanding. Space was stretching, growing between the clusters of stars. This means the terrible distances separating us from the rest of the cosmos are actively increasing every single second. The gaps between the galactic islands are widening, driven by an invisible mechanism that permeates the entire structure of reality. And this expansion is accelerating. The void is weaponizing its own emptiness, creating more space between us and everything else faster than light can ever hope to cross it. The deep darkness is not just a passive barrier. It is an active engine of isolation, ensuring that our view of the cosmos will eventually fade as distant galaxies are swept over the horizon of the observable universe, forever lost to the stretching of time and space. We are not just isolated, we are being actively pulled apart from the rest of creation. If you seek the truth hidden within the dark, if you are drawn to the unrelenting reality of our cosmic isolation, subscribe and join us as we journey further into the profound silence of the unknown. To understand the true mechanical horror of the expanding void, we must examine the physical act of looking across it. We possess an innate biological flaw, a tendency to view the images captured by deep space observatories as simple photographs, much like the pictures we take on our terrestrial devices. But a telescope operating in the deep vacuum of space is not a camera recording a live event. It is a highly specialized piece of forensic engineering designed to capture the microscopic decaying debris of dead epochs. To observe the extreme distances of the cosmos is to sift through a crime scene billions of years after the perpetrators have vanished. Consider the James Webb Space Telescope, a machine currently suspended in the freezing vacuum 1 million miles from Earth at a gravitational balancing point known as Lagrange Point 2. It was not built to capture the visible light that human eyes can process. The immense distances of the early universe render visible light entirely useless. As a photon begins its journey from a primordial galaxy formed near the dawn of time, it must travel across the expanding fabric of space. Because space itself is stretching, the physical wavelength of the light is stretched along with it. A tight, energetic wave of ultraviolet radiation emitted by the violent birth of a massive star 13 billion years ago spends eons crossing the void. As it travels, the expansion of the universe elongates the wave, pulling it out like a decaying rubber band losing its tension. By the time that light reaches our solar system, it has been stretched so severely that it has fallen completely off the visible spectrum. It has become infrared radiation, a faint ghostly signature of heat. To catch these exhausted, dying photons, the observatory must operate in conditions of extreme thermal isolation. If the telescope's own instruments were even marginally warm, the infrared radiation generated by the machine's own circuits would completely blind its sensors, washing out the microscopic signals from the deep universe. Therefore, it sits behind a massive 5-layer shield of metallized kapton, the size of a tennis court, which permanently blocks the heat of the sun, the Earth, and the Moon. On the dark side of the shield, the temperature plunges to almost 400 degrees below 0 Fahrenheit. Here, 18 hexagonal segments of polished beryllium, plated in a microscopically thin layer of gold, wait in the absolute dark. They wait for a single stretched photon, a relic that has been flying through empty space since before the Earth was a cloud of dust, to strike the mirror and generate a microscopic electrical charge. When we look at the breathtaking images of deep-field galaxies, we are not seeing a vibrant living universe. We are looking at a localized thermal map of ancient ghosts, reconstructed from the weakest possible traces of energy. The sheer volume of space that these photons must traverse introduces a terrifying mathematical reality regarding our map of the cosmos. Our entire understanding of the universe is constrained by a strict, spherical boundary called the observable universe. This is not a physical wall. It is a horizon of causality dictated by the speed of light and the age of the cosmos. Because the universe is roughly 13.8 billion years old, we can only see objects whose light has had enough time to reach us within that exact time frame. Anything beyond that distance is fundamentally invisible. But because the universe has been actively expanding during those 13.8 billion years, the objects that emitted that ancient light have been carried much further away. The actual edge of the observable universe is currently estimated to be 46 billion light-years away in every direction. This creates a sphere 92 billion light-years across, containing roughly 2 trillion galaxies, each harboring billions of stars. The scale is so mathematically aggressive that it shatters our cognitive limits. But the true horror lies in what is happening to the space inside that sphere. As the expansion of the universe accelerates, driven by the unseen mechanism we call dark energy, the space between galaxy clusters is multiplying. The galaxies themselves are not moving through space at these incredible speeds. The vacuum between them is regenerating, creating more nothingness. This means that galaxies currently near the edge of our observable horizon are being pushed away from us at speeds mathematically faster than the speed of light. They are not violating the laws of physics because nothing is moving through space faster than causality allows. Rather, the space itself is expanding at an accelerated rate, carrying the galaxies with it like rafts on a swelling ocean. Consequently, every single second, thousands of stars cross the cosmic event horizon. They slip beyond the absolute limit of observation. Their light will never reach us again. The observable universe is not gaining new territory. It is slowly, relentlessly bleeding out. We are living in a temporary, privileged epoch of cosmic history where the sky is still filled with the light of distant galaxies. If human civilization had evolved tens of billions of years in the future, the night sky would be completely barren. The expansion of the void would have pushed every other galaxy beyond the observable horizon. A future astronomer would look through a perfectly engineered telescope and see absolutely nothing but the dying embers of our own local group of stars. They would deduce from the sheer emptiness that our galaxy was the only object in the entire universe, and there would be no physical way to prove otherwise. This isolating mechanism is not just a theoretical fate. It is already dictating the architecture of our immediate cosmic neighborhood. When we map the distribution of galaxies within our observable sphere, we do not find an even homogeneous spread of matter. We find a violent, jagged web of superstructures separated by voids of incomprehensible size. The gravitational pull of dark matter has dragged galaxies into massive, glowing filaments, twisting through the dark like the neural pathways of a dead brain. And between these glowing threads are the cosmic voids. One of the most profound examples of this emptiness is located in the direction of the constellation Boötes. Discovered in 1981, the Boötes void is a spherical region of space roughly 330 million light-years in diameter. To understand the scale of this absence, consider our own Milky Way galaxy. The Milky Way is 100,000 light-years across. You could line up 3,300 Milky Way galaxies edge to edge, and they would only just bridge the diameter of the Boötes void. According to standard cosmological models, a region of space this massive should contain approximately 10,000 galaxies. After decades of scanning this dark coordinate with the most powerful radio and optical telescopes on Earth, astronomers have found only about 60. It is a statistical anomaly that deeply disturbs the foundations of astrophysical models. Voids of this magnitude do not simply form. The universe has not existed long enough for gravity to clear out a spherical region of that sheer volume through normal mechanical processes. The leading consensus suggests that the Boötes void is the result of multiple smaller voids colliding and merging over billions of years, much like smaller soap bubbles coalescing into one massive, fragile dome. The 60 galaxies trapped inside are scattered so far apart from one another that they exist in a state of absolute, unbreakable quarantine. The distance between them is so severe that the light from one galaxy barely registers as a faint smudge to its neighbor. The void acts as a localized prison of dark energy, where the expansion of space easily overpowers the weak gravitational bonds between the isolated star clusters. Yet, as we stare out into these terrifying oceans of emptiness, we are simultaneously blinded to what is happening in our own backyard. For all our highly advanced orbital observatories and deep-field spectroscopy, there is a massive, structural flaw in our ability to view the universe, a flaw born from our own physical location. We live inside the disk of a spiral galaxy. The Milky Way is a flat, rotating structure filled with hundreds of billions of stars, massive clouds of dense molecular gas, and thick, suffocating bands of cosmic dust. Because our solar system is embedded deep within one of the spiral arms, looking out into the wider universe is like trying to look out the window of a brightly lit room into the dark night. The glare and the structure of our own environment obscure the view. This massive obstruction is known in astrophysics as the zone of avoidance. Roughly 20% of the entire night sky, an enormous continuous band wrapping around the celestial sphere, is completely blocked by the dust and gas of our own galaxy. The visual and ultraviolet light from the deep universe simply cannot penetrate the dense particulate matter of the Milky Way's galactic plane. For decades, astronomers mapping the large-scale structure of the cosmos had to simply leave a massive, glaring blind spot in their maps, a dark band where data ceased to exist. We were attempting to chart an ocean while ignoring an entire hemisphere. It was not until the advancement of deep space radio astronomy and advanced infrared surveys, wavelengths that can punch through the choking dust lanes, that we began to peer into the zone of avoidance. And what we discovered hidden behind our own galaxy was not empty space. It was a gravitational anomaly of terrifying proportions. By analyzing the redshift and the peculiar velocities of galaxies in our broader cosmic neighborhood, astrophysicists realized that our entire local group of galaxies, including the Milky Way and Andromeda, is not just drifting aimlessly. We are moving. We are being violently pulled through space at approximately 1.3 million miles per hour. We are rushing headlong toward a specific coordinate hidden deep within the zone of avoidance, drawn by the immense gravitational mass of something we could not even see. This unseen mass was ominously named the Great Attractor. The mathematics required to generate a gravitational pull strong enough to drag hundreds of thousands of galaxies across millions of light years at millions of miles per hour are staggering. The mass of the Great Attractor was calculated to be tens of thousands of times greater than the mass of our entire Milky Way. For years it remained a terrifying specter in the data, a colossal, invisible mechanism exerting its will on our entire region of the universe. Through painstaking high-latency observation, using X-ray telescopes that could detect the incredibly hot gas surrounding massive galaxy clusters, the shape of the dark began to resolve. The Great Attractor is not a single dense object, like an impossibly massive black hole. It is the gravitational focal point of a staggering superstructure of galaxies known as the Laniakea supercluster. Laniakea, translating to immeasurable heaven, is our true cosmic home. It is a branching arterial network containing roughly 100,000 galaxies spanning a distance of over 520 million light-years. The mass of this superstructure is concentrated in a dense central hub, a gravitational watershed that dictates the flow of entire galaxy groups. The realization that our galaxy is part of this massive flowing structure forces a devastating shift in perspective. We are not stationary observers looking out into the dark. We are debris, caught in a microscopic localized current, being dragged toward the dense core of a superstructure that is itself being pushed apart by the relentless expansion of the vacuum. The sheer kinetic energy involved in the movement of Laniakea reduces the Earth to a subatomic particle swept up in a hurricane. And yet, this entire local mechanical drama, this movement of 100,000 galaxies across hundreds of millions of light-years, is practically irrelevant when compared to the barrier that surrounds it. Even our frantic millions of miles per hour plunge toward the heart of the Laniakea supercluster is an illusion of progress. It is a local drift masquerading as a journey. When we step back from the glowing arterial pathways of our local galaxies and confront the sheer mathematical reality of the wider void, we hit a physical wall where human ambition simply fractures. The barrier separating us from the rest of the cosmos is not merely a matter of technological infancy, a problem waiting for a better engine or a more efficient fuel source. The barrier is woven into the fundamental architecture of reality itself. It is a strict, inescapable set of mathematical laws designed, almost seemingly with malice, to keep the universe forever quarantined. To understand the absolute nature of this prison, we must confront the central pillar of modern physics, the theory of relativity, and how it actively conspires against our movement. A century ago, Albert Einstein proved that space and time are not a static stage where events simply happen. They are a single, pliable fabric, intricately bound together. And the absolute uncompromising dictator of this fabric is the speed of light. We are taught to think of light speed as a velocity, but that is a dangerous oversimplification. The speed of light is the geometry of the universe. It is the ratio by which space and time convert into one another. When you attempt to move through the vacuum of space, you are not simply changing your location. You are fighting the foundational math of reality. The laws of relativity dictate a brutal, inescapable tax on acceleration. As an object moves faster, approaching the ultimate speed limit, the kinetic energy required to push it begins to convert into mass. The faster you go, the heavier you become. This is not a metaphor, it is a literal mechanical truth. If we were to build a theoretical spacecraft and accelerate it to 99% of the speed of light, the ship would not just be traveling incredibly fast. From the perspective of the universe, it would become impossibly massive. To push that newly massive ship even a fraction of a percent faster would require an exponentially larger amount of energy. As you edge closer and closer to that absolute limit, the mathematics become terrifyingly clear. To accelerate even a single atom to the exact speed of light would require an infinite amount of energy. You would need to consume the entire mass of the universe just to move a single grain of sand at the speed of causality. Therefore, the speed of light is an asymptote, a mathematical line that we can approach but are physically barred from ever crossing. The universe has installed a hard lock on the door. It allows us to look through the keyhole at the distant galaxies, but the mechanics of mass and energy absolutely guarantee that we can never reach out and touch them. Yet, even if we accept this absolute limit, even if we resign ourselves to traveling at a fraction of light speed over tens of thousands of years, the void itself weaponizes our momentum against us. Our biological intuition assumes that empty space is, by definition, empty, a frictionless vacuum where a ship could glide forever. But the interstellar medium is not a perfect vacuum. It is littered with stray atoms of hydrogen, microscopic grains of ancient cosmic dust, and wandering subatomic particles. When you are drifting slowly, these particles are entirely harmless, but the physics of kinetic energy is merciless. Kinetic energy does not scale linearly with speed, it scales with the square of the speed. This means that if you double your velocity, the destructive energy of an impact does not double, it quadruples. If human engineers somehow manage to build a probe capable of traveling at just 20% the speed of light, a velocity necessary to reach the nearest star within a human lifetime, the very fabric of the void becomes a meat grinder. At those immense speeds, a single stationary atom of hydrogen floating in the dark ceases to be a harmless gas. From the perspective of the fast-moving ship, that atom slams into the hull like a high-energy particle beam. A microscopic grain of rock, no larger than a speck of talcum powder, would strike the vessel with the explosive force of a conventional military bomb. To travel fast enough to cross the cosmic distances is to subject yourself to a relentless, devastating bombardment by the very emptiness of space. The faster you try to escape your isolation, the more violently the universe attempts to tear you apart. But the horror deepens when we push past the physical limitations of spacecraft and look at the deep, theoretical foundation of the void itself. When physicists attempt to understand the true nature of empty space, they are forced to combine our two most successful, yet fundamentally incompatible frameworks of reality. On one side, we have general relativity, the mathematics of the massive, describing how gravity shapes the cosmos. On the other side, we have quantum mechanics, the bizarre, chaotic rulebook that governs the subatomic realm. When we try to use these two theories to describe the deep vacuum, human science encounters its most humiliating and terrifying failure. According to quantum mechanics, empty space is never truly empty. The uncertainty principle dictates that absolute zero energy is an impossibility. If we take a region of deep space, remove every star, every planet, every single atom, and block out all passing light, the remaining void is not dead. It is boiling. At the microscopic level, empty space is a raging ocean of virtual particles, fleeting fragments of matter and antimatter that violently pop into existence, borrow energy from the vacuum, and instantly annihilate each other in microscopic flashes. This is not theory. This quantum boiling is a proven, measurable reality. The vacuum has an intrinsic energy, a hum of violent, invisible activity. The nightmare begins when physicists attempt to calculate exactly how much energy is contained within this empty space. When the equations of quantum mechanics are applied to the vacuum, the math spirals out of control. The equations predict an amount of energy so violently massive that the numbers lose all connection to human comprehension. The theory suggests that the empty vacuum of space should contain a density of energy that is 120 orders of magnitude larger than what we actually observe. To put that mathematical catastrophe into perspective, A 120 order of magnitude error is not like miscalculating the distance to the moon by a few miles. It is a 1 followed by 120 zeros. It is a number larger than the total count of every single subatomic particle in the entire observable universe. It is famously known as the worst prediction in the entire history of physics. If the quantum mathematics were correct, the sheer amount of energy hiding in the empty space of a single coffee cup would be enough to boil all the oceans on Earth. If this theoretical vacuum energy were real, its gravitational repulsion would be so unimaginably catastrophic that the entire universe would have ripped itself apart into isolated, individual subatomic particles milliseconds after the Big Bang. Stars could never have formed. Galaxies could never have spun. Reality as we know it would be physically impossible. And yet, here we are. The universe exists. The galaxies hold their shape. The vacuum is entirely calm. The observable reality completely contradicts the foundational mathematics of our most advanced sciences. This is known as the cosmological constant problem, or the vacuum catastrophe. It is a gaping, bleeding wound in our understanding of physics. It tells us with brutal clarity that there is something fundamentally catastrophically wrong with how we understand the basic fabric of existence. The rules that govern the microscopic world and the rules that govern the cosmic scale are engaged in a mathematical war, and the empty void is the battlefield where human knowledge simply surrenders. This deep theoretical failure is not just an academic curiosity. It is intimately tied to the ultimate fate of our isolation. As we observed earlier, the universe is expanding, and that expansion is accelerating. The void is actively stretching, driven by the elusive force we call dark energy. Because our mathematics break down so completely when trying to calculate the energy of empty space, we are entirely blind to the true nature of this dark energy. We can measure its effects, we can watch it rip the cosmic web apart, but we have absolutely no idea what it actually is or why it has decided to wake up in this specific epoch of cosmic history. The accelerating expansion of the universe creates a phenomenon that directly challenges the very concept of physical reality. As dark energy stretches the void, galaxies at the extreme edge of our vision are pushed away faster than the speed of light. When this happens, they cross the cosmic event horizon. But this is not simply a matter of a star fading from view. According to the strict rules of physics, when an object crosses that boundary, all the information it contains, its history, its chemical composition, its very existence, is permanently deleted from our accessible universe. In physics, the conservation of information is a sacred principle. The idea that you can destroy information completely is a paradox that threatens to break the laws of thermodynamics. Yet, the cosmic horizon does exactly that. The universe is acting like a massive, uncaring machine, systematically permanently erasing vast swathes of its own architecture from our reality. We are trapped inside a spherical boundary that is effectively a reverse black hole. Instead of matter falling in and being crushed, the universe is falling outward, slipping over an invisible edge into an absolute, mathematical nowhere. We are left stranded in the center of a paradox. The physical laws restrict us to a microscopic speed limit, trapping our bodies in a fragile solar system. The physics of kinetic energy turn any attempt to cross the void into an act of violent self-destruction. And when we try to use our intellect to understand the sheer emptiness surrounding us, our mathematics collapse into absurd contradictions. The universe is not merely vast, it is architecturally designed to remain forever beyond our grasp. A magnificent, terrifying machine that operates on principles we are fundamentally barred from ever touching. If we are permanently trapped within a localized sphere of reality, barred from traversing the void by the brutal mathematics of kinetic energy and the absolute speed limit of causality, we might seek comfort in the idea of shared time. We intuitively believe that even if we cannot physically reach the distant galaxies, we are all at least existing simultaneously. We assume there is a universal clock ticking away, a shared present moment that binds the cosmos together. But the staggering distances of the universe shatter this comforting illusion just as violently as they shatter our dreams of physical exploration. The concept of now is a biological fabrication. a local convenience engineered by our brains to process our immediate surroundings. On a cosmic scale, the present tense simply does not exist. To understand the depth of time coordination, we must return to the behavior of light. Because information takes time to cross the vacuum, and because the distances are so unfathomably vast, the universe operates on a system of massive, inescapable latency. But this latency is not uniform. It is relative to the observer. Imagine a star exploding in a distant galaxy. For the star itself, the violent collapse of its core and the subsequent supernova happen in its own immediate present. But for a hypothetical civilization living on a planet 1,000 light-years away, that event has not yet occurred. It will not occur for a millennium. And for us, observing from Earth 1 billion light-years in the opposite direction, the star is still burning peacefully, and it will continue to do so for an eon. There is no single objective vantage point from which the universe can be viewed in real time. This means that the entire structure of the cosmos is chronologically fragmented. Reality is entirely dependent on where you are standing. If we were to somehow establish a communication link with an intelligent civilization in the Andromeda Galaxy, we could never have a conversation. Even if we used powerful directed lasers to send a message at the speed of light, it would take 2.5 million years for our signal to reach them, and another 2.5 million years for their reply to return. Our simple exchange of greetings would require 5 million years, a span of time during which our entire species could evolve into something unrecognizable or go completely extinct. The distance turns communication into an archaeological exercise. You are never speaking to a living entity. You are only ever leaving a voicemail for a civilization that might already be dead by the time the transmission arrives, and you are receiving responses from ghosts. This extreme chronological isolation provides a chilling, purely physical solution to one of the most profound mysteries of modern astronomy. For decades, scientists have scanned the skies, listening for the faint radio whispers of advanced civilizations. The sheer number of stars in the observable universe, combined with the billions of years of cosmic history, suggests that life should be abundant. We should be seeing the grand engineering projects of ancient, galaxy-spanning empires. We should be detecting the thermal exhaust of thousands of alien worlds. And yet the sky is completely silent. We call this the Fermi paradox. But when you factor in the sheer, unyielding mechanics of cosmic distance, the paradox vanishes, replaced by a grim thermodynamic reality. Building a galactic empire requires the movement of either information or physical matter. But as we have established, the distance makes real-time coordination impossible. An empire cannot function if its capital city takes 100,000 years to issue an order to a border colony. Furthermore, the energy required to project power or presence across the void is mathematically prohibitive. To send a self-replicating robotic probe to another star system requires accelerating a mass to a significant fraction of the speed of light, shielding it from the devastating kinetic impacts of interstellar dust, and providing it with enough energy to decelerate upon arrival. The energy density required for such an endeavor dwarfs the total energy output of our entire planet. Even if a civilization managed to harvest the entire energy of its local star, enclosing it in a massive theoretical shell to capture every photon, the laws of thermodynamics dictate a brutal truth. Energy dissipates. As a signal or a physical object travels across the expanding void, it is subjected to the inverse square law. The intensity of an energy source drops exponentially as it spreads out over the vast volume of space. A tightly focused laser beam sent across 1 million light-years will eventually lose its cohesion, spreading out and scattering against the faint traces of cosmic gas until it becomes indistinguishable from the background radiation of the universe. The distances are so great that they act as a universal silencer, dampening the energetic signatures of any civilization and grinding their ambitions to dust. We do not hear anyone else in the dark because the dark is too deep, acting as a perfect, insurmountable quarantine that enforces absolute solitary confinement on every spark of life that happens to ignite. While the expanding void aggressively isolates us from the rest of the cosmos, our immediate localized future is dictated by a different, incredibly violent physical mechanism. The stretching of space is currently tearing the distant superclusters apart, but gravity is still the dominant force within our local neighborhood. And gravity is pulling us toward a catastrophic collision. As we peer through the obscuring dust of our own Milky Way, tracking the movement of the Andromeda Galaxy, we do not see its light shifting toward the red end of the spectrum. Andromeda is not being carried away by the expansion of space. It is shifting toward the blue. It is falling directly toward us at a speed of roughly 250,000 miles per hour. The space between our two massive galaxies is roughly 2.5 million light-years, a gap that seems insurmountable. But gravity is relentless. Every single day, the distance between the Milky Way and Andromeda shrinks by millions of miles. Because the speed of light is incredibly slow relative to this distance, our current view of Andromeda is an ancient snapshot. We see it as a distant, peaceful smudge of light. But the physical reality of the mass is already much closer. Over the next 4 billion years, the night sky of Earth will undergo a terrifying transformation. If human descendants or any terrestrial life forms are still here to witness it, the faint smudge of Andromeda will grow until it dominates the entire celestial hemisphere. It will cease to look like a distant object and will appear as an impending glowing wall of gas and ancient stars, rushing toward us with the kinetic energy of 1 trillion suns. When the collision finally occurs, it will not be a sudden, crashing impact. The distances between individual stars within a galaxy are so vast that it is highly unlikely any two stars will physically strike each other. If you were to scale stars down to the size of ping-pong balls, they would still be separated by hundreds of miles of empty air. Instead, the collision will be an agonizing, drawn-out, gravitational, slow-motion train wreck lasting for hundreds of millions of years. The immense supermassive black holes at the centers of both galaxies will lock into a decaying binary orbit, violently churning the surrounding architecture of space. The true violence will occur within the massive invisible clouds of cold molecular hydrogen gas that permeate both galaxies. As these titanic clouds slam into each other at millions of miles per hour, the friction will generate immense shock waves, compressing the gas and triggering a chaotic, furious firestorm of starbirth. The night sky will blaze with the blinding blue and white light of millions of massive, short-lived stars, illuminating the wreckage of our galactic home. This explosive period of star formation will quickly consume the remaining raw materials of both galaxies. Simultaneously, the delicate, sweeping spiral arms of the Milky Way, the beautiful structures that have defined our galaxy for billions of years, will be utterly destroyed. The immense gravitational tides will violently tear stars from their orbits, flinging entire solar systems out into the freezing, intergalactic void. Trillions of planets will be ejected from the warm embrace of their host galaxies, condemned to drift endlessly through the pitch-black ocean of empty space as rogue worlds, their surfaces freezing solid as they leave the light behind. Eventually, the chaos will settle. The two galaxies will merge into a single, massive, featureless elliptical galaxy, a glowing, bloated sphere of aging stars that astronomers have preemptively named Milkdromeda. The beautiful organized rotation of the spiral will be gone, replaced by a chaotic swarm of stars buzzing around a newly merged, ultra-massive central black hole. And it is inside this dead, red elliptical galaxy that our descendants will face the true, ultimate consequences of cosmic isolation. By the time Milkdromeda is fully formed, the relentless engine of dark energy will have completed its work on the wider universe. The expansion of space will have pushed every other galaxy, every other cluster and every other structure beyond the observable horizon. The light from the rest of the cosmos will simply no longer be able to reach us. The sky outside our newly merged supergalaxy will be absolutely permanently black. There will be no background radiation to study, no distant quasars to map, no physical evidence that the universe extends beyond the boundary of Milkdromeda. The isolation will be absolute and irreversible. Trapped within this singular lonely fortress, the universe will begin its long, slow descent into the degenerate era. The violent firestorm of starbirth that accompanied the collision will have exhausted the local supply of free hydrogen gas. Without this crucial fuel, the engine of the cosmos will begin to sputter and die. No new stars will be born. The brilliant massive blue stars that light up the spiral arms today will burn through their fuel in a few million years, detonating in spectacular supernovae and leaving behind dark, dense remnants. The night sky will be dominated by red dwarfs, tiny, incredibly efficient stars that burn their hydrogen fuel at a glacial pace. These dim, crimson embers can survive for trillions of years. They will become the last outposts of warmth and light in a dying universe. Any surviving life will be forced to huddle close to these fading red fires, their planetary orbits tightening, desperate to capture the last remaining scraps of thermal energy. But even these enduring stars are not immortal. Eventually, trillions of years in the future, the last red dwarf will exhaust its fuel. It will not explode. It will simply fade, cooling down to become a theoretical object known as a black dwarf, a dense sphere of degenerate carbon and oxygen, radiating absolutely no heat, entirely invisible against the backdrop of the void. When the last star goes out, the universe will enter a period of darkness so profound and so prolonged that the entire history of starlight, the billions of years of galaxies and planets and life, will be reduced to a fleeting, microscopic spark in the absolute beginning of time. The cosmos will belong entirely to the dead remnants. Black dwarfs, freezing neutron stars, and scattered rogue planets will drift aimlessly through an ever-expanding, pitch-black void. The temperature of the universe will plummet to a fraction of a degree above absolute zero, but the architecture of the dark will still be dominated by the most terrifying objects physics allows to exist: black holes, the supermassive monsters at the centers of the dead galaxies, and the smaller stellar mass black holes scattered throughout the ruins will patiently wait in the dark. For an incomprehensible stretch of time, they will slowly consume the drifting dead stars and rogue planets that wander too close to their gravitational wells, crushing matter out of existence and adding to their massive bulk. Yet, the mathematics reveal a merciless truth, even for these immortal titans. They are not permanent. In the 1970s, physicist Stephen Hawking demonstrated that the laws of quantum mechanics, the very same boiling activity of the vacuum that breaks our understanding of empty space, act upon the event horizons of black holes. Because pairs of virtual particles are constantly popping into existence in the vacuum of space, occasionally one particle will fall past the event horizon while the other escapes into the void. To balance the books of thermodynamics, the escaping particle drains a microscopic fraction of the black hole's mass. This process is excruciatingly slow. For a supermassive black hole to evaporate entirely through this mechanism would take a number of years represented by a 1 followed by 100 zeros, a span of time known as a googol. But in the deep future of the isolated cosmos, time is the only thing left in abundance. Slowly, atom by atom, the black holes will begin to bleed their mass into the freezing vacuum. The mathematics reveal a merciless truth. The smaller the black hole becomes, the hotter it burns, accelerating its own evaporation into the void. In their final moments, they will detonate in a flash of high-energy gamma rays, a final silent firework illuminating a completely empty space. When the final black hole evaporates, shedding its last particles into the ever-stretching nothingness, the physical universe as we understand it will cease to possess any meaningful structure. The immense distances that currently terrify us, the billions of light-years of empty space separating the galactic islands, are merely a temporary preamble to a much deeper, more fundamental dissolution. The void is not simply pushing the galaxies apart. It is preparing the stage for an era where the brutal laws of thermodynamics will hunt down the final remnants of matter, threatening to break apart the very atomic structure of the dead worlds left drifting in the permanent dark. When we confront this ultimate timeline, the dissolution of reality itself, the human perspective completely shatters. We are biologically obsessed with legacy. We build monuments of stone and steel. We carve our faces into the sides of mountains, and we broadcast our radio voices into the static, desperate to leave a permanent mark on the universe. We measure significance in centuries, or at the absolute most, millennia. But against the deep, unforgiving time of the cosmos, the entire human story, from the first spark of fire in a freezing cave to the last dying breath of our advanced civilization, is not even a fraction of a second. It is a microscopic chemical fluctuation on a single grain of silicate dust, instantly swallowed by a crushing infinite silence. For thousands of years, our evolutionary biology and our arrogance convinced us that we were the focal point of creation. We placed the Earth at the center of the solar system, and then we placed our solar system at the center of the galaxy. Even when the telescope stripped away these comforting illusions, proving our cosmic insignificance, we still desperately clung to the belief that the universe was somehow made for us, a grand frontier waiting to be conquered. But the unyielding coldness of the data tells a brutally different story. The universe is not a canvas for human ambition. It is a hostile, decaying machine that does not know we are here, and it will not notice when we are gone. The colossal voids, the accelerating expansion of the vacuum, the absolute physical barriers of light and time, these are not challenges meant to be overcome by human ingenuity. They are the fundamental parameters of a quarantine. We are prisoners of scale, trapped in a localized bubble, allowed only to watch as the rest of creation recedes into an unreachable, permanent dark. And yet, the true horror is not just the eventual death of the stars or the future stretching of the void. The true horror is our immediate current isolation. Right now, as you sit breathing the oxygen of this fragile atmosphere, the barrier is active. We are entirely alone in an ocean of impossible distances. If there are others out there, other biological anomalies waking up in the dark across the universe, they are trapped exactly as we are, bound by the excruciatingly slow speed of light, silenced by the stretching of space, condemned to live and die in solitary confinement. We cannot reach them. They cannot reach us. The universe has ensured that every tragedy, every triumph, every catastrophic war, and every profound discovery that occurs on this planet is completely meaningless to the wider cosmos. The light from our sun is just one more fading spark in a dying neighborhood, and the radio whispers of our civilization will eventually scatter and fade into the cosmic background, unheard and unrecorded. Let us examine the human concept of memory. We believe that as long as something is remembered, it holds inherent value. We store petabytes of data, digitizing our history, our art, and our science, hoping to create an immortal archive of the human experience. We launch probes carrying golden records into the abyss, foolishly hoping that some distant advanced intellect will one day find them and know who we were. But the physical laws of thermodynamics dictate the absolute erasure of all memory. As the galaxies retreat over the cosmic horizon, as the red dwarfs burn out and the black holes evaporate, the universe is systematically destroying the physical capacity for memory to exist. Information requires energy to be stored and processed. In the deep future, when the temperature of the cosmos reaches absolute zero and the last remaining matter decays, there will be no energy left to hold a thought, to process a digital record, or to perceive the passage of time. The universe will not simply forget us. It will lose the fundamental mechanism required to remember anything at all. Everything we have ever done, every tear shed, every mathematical equation solved, will be as if it never happened. The slate is not just wiped clean, the slate itself is destroyed. It is here, in the face of this absolute physical erasure, that the human mind attempts to rebel. We try to find philosophical loopholes in the math. We argue that the brevity of our existence is exactly what makes it beautiful. We tell ourselves that meaning is a localized phenomenon generated by our own minds and therefore valid even in a dying, meaningless universe. We look at the terrifying expanse of the Boötes void or the violent future collision with Andromeda, and we try to romanticize them as grand cosmic poetry. But this is just another biological coping mechanism, a psychological shield designed to protect our fragile consciousness from the crushing weight of reality. The universe does not care about our localized meaning. The cold, raw data of astrophysics offers no comfort, no redemption, and no underlying purpose. There is no grand design, no ultimate destination, and no cosmic audience watching our struggle. We are simply a temporary arrangement of atoms, briefly capable of understanding our own doom, trapped on a rock falling through a vacuum that is actively trying to pull itself apart. The next time you look up at the night sky, do not see it as a beautiful canopy of stars. See it for what the mathematics and the physics prove it to be, It is a graveyard of delayed echoes. It is an actively expanding gulf of nothingness that enforces a strict, unbreakable quarantine. The darkness between the stars is not empty space. It is a physical barrier of extreme hostility, stretching faster than the speed of causality, permanently severing us from the rest of reality. We are born in the dark, we will live in the dark, and we will eventually be swallowed by the dark. There is no escape, there is no rescue. There is only the relentless, silent math of the void, calculating the final, inevitable zero.